Hello there. Today we're going to move on to scientific notation. Now, some of you may already have seen scientific notation as part of your work in physics, chemistry, or biology. Don't worry if you haven't seen it yet. You'll learn it, you'll pick up very quickly here. Scientific notation is our way of writing down very large numbers or very small numbers. So for example, if we think about the distance between stars and galaxies, those numbers are immensely huge in terms of, well, we don't even think about kilometers, we would think about light years. And even then, it's many millions and billions of light years apart. So really big numbers that we have to write in a very small, concise way. And it's the exact same with the size of, well, I suppose I've written down here the size of a virus or an atom. So scientists just now, when they're measuring the impact of the size of the coronavirus, then they're dealing with very small numbers here. So we're not talking about millimeters, we're talking about many orders of magnitude smaller than millimeters. So small that you need a very powerful microscope in order to see the virus up close. But there's a very simple way of writing these numbers. And what we do is we write it, the number, whether it be very big or very small, in terms of powers of 10. So you may have already noticed, especially if you have a Casio calculator, that if you're dealing with very big numbers, your calculator can only see a certain size of number, usually 10 or 12 digits. Any bigger than that, the calculator will put it into scientific notation. And in order for us to deal with that, we need to look at the string of numbers that we have, and we need to write it down so that our scientific notation number always starts with a number between 1 and 10, not including 1 and not including 10. So for example, let's start off with this number here, 5,600,000. I'm going to give you just a bit of a longer explanation how we get the scientific notation number. So first of all, what we can do here is we can think of 5,600,000 as being multiplied by 10 to the power of 0. Now, hopefully you will remember from our work on indices, there's a special law of indices that says that anything to the power of 0 always gives you 1. So here we have 5,600,000 multiplied by 10 to the power of 0, which is the same as multiplying by 1, and it stays the same. That's the exact same as taking 560,000 and multiplying it by 10, which is the same as saying 56,000 multiplied by 10 squared, which is 100. It's the same as saying 5,600 times 10 cubed, which is 1,000. 560 times 10 to the power 4, 56 times 10 to the power 5, or 5.6 times 10 to the power 6. And we keep that process going until we get to that last stage there, where we have this number here as the number that's between it's between 1 and 10. Once we get that number, that's when we stop. The amount of times that we multiply that number by 10 becomes the power, and this whole thing here is scientific notation form. Sometimes we call it standard form, sometimes it's called scientific notation. It means the exact same thing. We do the exact same thing when we think of very small numbers. So for example, if I've got the number 0.0000056. Again, if I multiply it by 10 to the power 0, same as multiplying by 1. But if I then start to multiply by 10 to the power of a negative number, we then start to get the number to be that number between 1 and 10 from the opposite direction. And for that, we think of our other index law that says a to the power minus m is 1 over a to the power of m. So if I am multiplying 0.000056 by 10 to the power minus 1, that's the exact same as multiplying by 1 over 10 to the power of 1. So you're multiplying by a tenth, which actually has the effect of making the number bigger. So we do that the same for times 10 to the power minus 2, minus 3, minus 4, minus 5, minus 6, and then we get back to that same situation where we have this leading number here as the number that's between 1 and 10, and this number here becomes the power. I don't expect you to go through this process for every single number. I've got a far quicker process that I want you to use, but that's just a bit of a background to show you how we change very big or very small numbers into scientific notation. And it all comes down to the bit that's in the grey box here. The number of jumps that the decimal point makes becomes the power. So if you bear in mind that large numbers have got positive powers and small numbers have negative powers, we'll look at the first example here. So it says that the distance from Earth to the Sun is 147 million kilometers. I want to write this number here in scientific notation. So in order to do that, all we do is we think, well, right now in that number, where is the decimal point? The decimal point is right here at the very end. So to make it into scientific notation, I have to make that decimal point jump from where it is so that I can make a number between 1 and 10. The only way to make a number between 1 and 10 for that number is to put the decimal point in here between the 1 and the 4 to make 1.47. And the number of jumps that it does becomes the power of scientific notation. So this is going to do 1, 2, 3, 4, 5, 6, 7, 8 jumps. Okay, so because the decimal point jumps 8 places, we get the leading number 1.47. The times 10 bit is the standard form part, that always stays the same. So it's 1.47 times 10 to the power of, and remember the amount of jumps that the decimal point did was 8. So 1.47 times 10 to the power of 8. That's it. Obviously we'll put in our units, kilometers. So really, if you listen to scientists won't really talk about millions of kilometers. They'll say that the distance from Earth to the Sun is 1.47 times 10 to the power 8 kilometers. It's a standard way to talk amongst the science community. In the second example here, we've got the width of a hydrogen atom. Very, very, very small. So it's 0.000000053 millimeters. So again, I want to make my number that's between 1 and 10. The only way to do that is to put my decimal point in between the 5 and the 3. So we can see where it is just now. So it's going to jump 1, 2, 3, 4, 5, 6, 7, 8 places. From where it is to where it has to be to make that number between 1 and 10. So we start off with the number between 1 and 10, which will be 5.3. Put in the standard form part because it's always a multiple of a power of 10. And remember, we jumped 8 places, but it's 8 places in the opposite direction because it's a very small number. So we say that it's going to be 5.3 times 10 to the power of minus 8 millimeters. That is the width of a hydrogen atom. We can change from scientific notation back into normal form just by undoing the process there, just by moving the decimal point back that number of places. So for example, if I had 2.97, and I'm looking at this example right here. If I have 2.97 times 10 to the power 5, if I wanted to change that back into normal form, then all I would do is I would move my decimal point 5 places back the way. So that would give me 297,000. So that would be 297,000. If I had, for example, the number 2.97 times 10 to the power of minus 5, and I wanted to turn that back into scientific notation, then I would just move my decimal point back the other way. Just remember, if it's a positive power, it becomes a huge number. If it's a negative power, it becomes a 0 point number. So the point would go back 5 places. So we'd get 0 points, and then we'd have 1, 2, 3, 4 zeros, 297.